Okay, so how we change the speed of sound or different speeds of sound. In order to change the speed of sound, we have to change the properties of the medium. And there's only two ways of doing that. First, we can change the stiffness or the rigidity of the medium. So by increasing the stiffness, it increases the speed of sound. The reason for that is that molecules are more linked to so that disturbances get transmitted faster. So you don't have a bunch of molecules very far apart. If that was the case, it would take time for one molecule to hit the other, sending the wave along. We can also change the density. By increasing the density, we're actually decreasing the speed of sound. So more massive means more inertia and resistance to change in position. So the density part is just because of inertia. And we know that inertia is the characteristic of something to not want to change its movement. So if it's more dense, it doesn't want to travel very fast. And we can follow this rule here that the velocity of sound, the speed of sound in a solid is fastest. The speed of sound in a liquid is going to be between a solid and gas, and the speed of sound in gases is actually going to be the slowest. So fastest, less fast, slowest. Let's talk about Mach numbers. I'm sure we've all heard of this in different movies. If you're talking about a plane, or maybe Mach numbers in like Star Wars or something. Mach numbers are multiple or fraction of speed of sound in that specific medium and conditions. Okay, so if we know the speed of sound in a given substance, let's say sea level, where it's 760 miles per hour, and I say that we're going Mach 2, what I'm going to do to figure out how fast this object is going is I'm going to take the number 2, multiply it by the speed of sound, 760, and that's going to give me the speed of whatever object that I'm talking about. So as we go up into higher in the elevation, we're going to see that there's a decrease in temperature. Cold air is more dense than hot air, which means that the speed of sound is going to be slower in cold air, right? An increase in density slows down the speed of sound. So if a plane is at a higher elevation, traveling at Mach 2, is it going to be going less than 1,520 miles per hour, exactly 1,520 miles per hour, or more than 1,520 miles per hour? Well, 1,520 is a multiple of 2 of 760. So at sea level, it would be going exactly 1,520 miles per hour. But at a higher elevation in cold air, the speed of sound is slower. So at sea level, it's 760 miles per hour. At a higher elevation, it might be something like 700 miles per hour. So going Mach 2 at 700 miles per hour is going to lower the speed of sound in that given medium, making it so if you're traveling Mach 2 at a higher elevation, it's going to be less than 1,520 miles per hour. If the speed of sound was 700 miles per hour, it would be going 1,400 miles per hour. So just a quick review of the characteristics of sound that you'll need to know. If I increase the amplitude, the density of the compressions, it's going to be a loud sound. If I decrease the amplitude, it's going to be a soft sound. If I increase the frequency, how many waves are going by a given moment in a second, it's going to increase the pitch, a higher pitch sound. And if I decrease the frequency, I'm going to get a lower pitch sound. We're going to talk about the Doppler effect. The Doppler effect is an increase or decrease in frequency of sound, light, or other waves as the source and observer move toward or away from each other. What this means is if something is making a sound, like an ambulance with its siren on, and it's moving towards you, as it sends out sound waves, those waves are going to become more compressed. And when those become more compressed, we increase the frequency of the direction the ambulance is going. So if you're standing in front of the ambulance, you're going to experience a sound with a higher frequency. That means that it's going to be a higher pitch as it approaches you. If you're standing away from it, the opposite happens in the opposite direction. So these waves are actually going to decrease its frequency because they're going to be more spread out. And therefore, this person behind is going to experience a lower frequency as it's traveling away. And we'll come back to this in just a moment.